Well, my name is Mike Leahy, and I run a company called EGR Software. And I just got to say, it's amazing to see all this this turnout. It's really great. I mean, when I saw that like 140 people signed up for the presentation, I was like, wow, you know, that's awesome. I don't think there's 140 people in this room necessarily, but you know, thanks guys for coming out. You know, I'm going to definitely talk about some topics that I'm really passionate about, and really, when it comes down to it, you might have also seen that this presentation got pushed back a month. I've been in a very heavy development phase, trying to finish up this middleware platform called TyphonRT, which is actually a project that I've been working on for about 7 years now, and in the last 18 months have spent almost full time porting it to Android. Now, I'm not sure if you guys are familiar with the concept of, or have heard about the lean startup situation, or movement, if you want to call it that. And you know, they got this concept called the MVP, or the most or minimum viable product. Well, today I'm going to give you my minimum viable presentation. So I've been working really hard to release TyphonRT. And I even really wanted to try to do a temporary code drop. I'm about 2-3 weeks out now with all the release engineering that has to go on. But, you know, I pushed really hard over the weekend. And, I mean, I've actually worked every single day of July so far on this. And not a lot of 8-hour days, a lot more longer length, length days. So I've certainly been putting in the time to try to just get this out and make it high quality. You know, that's something that can be lacking at times across the Android ecosystem, is the ease to actually create quality applications is pretty difficult. So I've actually been working with Java since 1996. I had the fortuitous occasion to actually do an internship before going to college, and my first task was, it was a web startup, mostly like a Perl-based company, and I was tasked to figure out what this Java thing was. You know, it's some crazy new thing, you could do these applets, you know, neat. You know, so that was my first task before college, and you know, I think I was actually working for free for a little bit. And then maybe a little minimum wage action, but that got me started in a whole trajectory that I've not only made it into a career, but it really is a calling. Like, I'm also applying Java and making real-time apps and this platform to do some larger things that are artistic oriented as well. And I'll show some pictures pretty soon of what I've been up to. But I mean, as far as Java goes, I've focused mostly on, again, real-time apps and graphics-oriented technology. And I've even worked with, I'm not too sure how many of you have heard of Netscape's Internet Foundation classes? So I was, cool. Which is it was the predecessor to Swing. And I did a pretty major project in that. So I hit some of these early technologies early on, and did a lot of Swing Java 2D stuff for most of you know, the last 10 years, and got started with desktop OpenGL development roughly about 2003, and that's right about where TyphonRT started. Certainly now in the last 18 months, quite a bit of, I mean, all Android. You know, once Android came out and I saw, you know, the possibilities with how I could, you know, move the majority of my work over to it, and just, I mean, simply the fact that, you know, everybody's going to have a mobile device, you know, literally, it's such a great teaching tool and very engaging when you consider all the sensors, all the additional things you could do interface-wise, that people just, it's a lot more engaging. Now, the one big industry success that I had, or you know, the time that I really you know, did some great work, was I was the first US developer at this company called Device Anywhere. So I'm not too sure if you guys have heard about it. Yeah, no, it's a really great solution to a very difficult problem. And it was mentioned last week or last month as well. And what they do is they reverse engineer cell phones and make it so you can kind of log into them like Timbuktu or PC, like PC Anywhere. And so you actually are able to use a real device remotely. So that's really good for, like, you know, testing any sort of different carrier experience. Like, say if it's a device is in Japan or Germany, the carrier experience can be completely different. And so I built out most of the features in that whole platform, and yeah, helped them become a big success. Now I want to kind of jump into the first demo, and it's one of the basic functionalities of TyphonRT, and that's clocking. Time is important, you know. I mean, everything that you do in a real-time application deals with time and the advancement of time. And one of the central clocking mechanisms is called the subdivided integer clock, which means essentially, like, you're able to run the clock so you get callbacks at 60 hertz or 60 cycles per second or frames per second, but you can subdivide it so that every other frame you can get a different callback. So you can get callbacks at 30, 20, 15, 10, and 5, all pretty reliably. So you might want your render loop running at 60, but you might want something else that doesn't need to be called as much to run at a lower clock rate. And I mean, even input or AI or something, you know, there's different things that you could assign that don't need to be called every frame that you render. It's also really kind of cool, especially when it comes to Android, is that you can catch exceptions on the clock thread. So if you have something that you've attached to it, I mean, you probably guys all have seen the force close. Errors that pop up in numerous applications, I'm sure. And it's a way to avoid that and catch an exception before it gets to Android. And you can respond with a much better message. And now Google did add to the SDK, I'm not sure which version, it's pretty recent, where it'll actually pop up a better message and be able to also send that data back to, you know, the marketplace or your app section. But you know, older devices, and there's tons out there, you know, you're just going to get that force close, and that's kind of annoying. Now, last month's presentation by Justin, developer advocate from Google, really focused on the resource section. You know, I forgot the video, so let's go to the video here. So this is an example of the subdivided integer clock. Once it Okay. So on the left here, when it says FPS, that's actually the clock FPS. So I'm calling at that, and the actual FPS is the actual what's happening on the display. And I have 5 or 6 different clockables, which is the interface that you use to attach something to the clock, getting called at different iterations. So you can see the and of course, it doesn't stutter in real life. It goes full speed ahead. You can see that I just have like basic counters counting up, and one's going a lot faster. I mean, the 60 hertz one is going to go was it 12 times faster than the 5 hertz one. Okay, so now I dropped, or you didn't see it, but. So I can take the view, or the clockable that is running at 60, and then attach it to a different subdivision, 15. So now the clock FPS and your view FPS is running at 15 hertz, and that's how you can actually frame limit things, and frame limit things properly. We'll actually be able to see a really gnarly demo of the Evo later, where they just, oh, now we're getting into fragmentation so soon. It's so easy. But yeah, the capping on the Evo is just absolutely horrible, and we'll take a look at it a little bit later. So I dropped it down to the 5 hertz, and again, it's kind of a bummer. It's a little stuttery. So you could see the bottom one, you know, update every click, but the top counter is actually still behind the scenes running full speed ahead. But the view is only updating at 5 hertz. So one of the good things about being able to disassociate the view from like the data models that you have, especially when it comes to like GUI development, is if you have a slower device and you have like a slider or something like that. I don't know how many people do Swing or Java 2D development. If you just use like the standard Swing, and why a lot of those applications suck, or it's just performance-wise kind of sucks, is that when you move a slider on Swing, you're getting like all these events, and it's trying to redraw really quickly. And I guess it's not so much of a problem, you know, now, but it was 10 years ago when computers were a lot slower. Well, back to this video here. Unfortunately, it's stuttering a little bit, but I basically have a different ability to set the background color, and in this simple little demo. And now that I set it at 60, we're at 30, so it's always going to appear red. But if you set the subdivision below 30 for the clock, which I do here, you'll actually get a flash. Well, I guess this is as good as any time to jump into a little bit more historical interest that I've had and why I created TyphonRT. And audio is, I'm really big into audio. And you know, when I graduated, you know, I did a lot of event production and a lot of music stuff in college, a lot of DJ for a long time. And I really wanted to get into audio development and DSP type development, but you know, I didn't want to go work for DigiDesign or like some corporate entity, which is kind of almost what you have to do for audio, which is unfortunate. So the really cool thing around 2002 and whatnot, there's an open source project called Super Collider, which is a DSP engine. I'm not too sure how many people do audio type stuff. Maybe you've heard of Reactor and some other like graphical patching applications where you can kind of patch a DSP situation together. Well, Super Collider is really cool. It's like a network server, and it uses something called Open Sound Control, so you can kind of send network data to this DSP server. But it didn't have a great GUI, so that's where TyphonRT started. You know, it started to create a real-time GUI interface to a DSP synthesis engine, and then it kind of blossomed out from there. But this is a installation that I did at Burning Man in 2003, where we had this 50,000 watt sound system set on like a 200 foot diameter circle, and I do a lot of stuff with a lot of audio development with a technique called ambisonics. And that's what we were doing out here. So you get it's an awesome spatial technology that's just not very popular, unfortunately. Oh man. Okay. So that's kind of what it looked like from a little afar. Well, that led me into I basically built this facility that you see right here. Over the last, I moved to it around 2006, and I basically built out this facility where I have a whole dome of speakers. And again, TyphonRT is going to be used to do a lot of the control data stuff. But where things really come into play with Android is that before Android, I was actually working with like a Linux distribution called UC Linux. And working with the Shark DSPs and the Blackfin devices. So I was already doing like firmware development type stuff. But when Android came and I saw the flexibility of not only being able to continue using Linux under the hood, but to be able to have a framework, and that's actually one of the first prototypes pre-Android. I mean, like basically where I'm going with this is that I'm going to be using Android as an operating system for audio hardware. At some point in time, and TyphonRT is going to be not only the platform, the middleware platform that runs on the desktop so you can write applications for it, but it's also going to run on the actual hardware itself to provide the interface and also to provide a way, so very much like there's an app store for devices, that's what 24 speakers look like when they show up to your house. All right. So yeah, last month's presentation, we had Justin from Google that talked about the resource system But, you know, he kind of approached it from the direction of just general application development. So some of the things that he mentioned, you don't want to do if you're doing real-time games and applications. One of the big key things that if you do nothing, and you guys might have seen this, or I'm sure most of you have an Android device at this point, if you're really into it. When you swap, or if you have a device without a keyboard and you swap the orientation, by default, it'll actually stop the activity and restart it. And there's the resource system. You can choose to do this where you could have resources for landscape and portrait mode, but you really don't want to like stop and restart a real-time application every time you flip the phone like that, because that messes up everything. So you really want to not do that. But if you not do that, you have to manage all those switches of orientation yourself. And I didn't get to put a little bit of code up, but if you guys have been Java developers for a while, you might recall the change listener event system, where you can register as a listener and receive change events. Built into TyphonRT is what's called the ID change listener system, which is very similar to a change listener interface, but you have an integer ID with it, so it makes parsing the messages that you get, or the events that you get, a lot quicker. Because if you could just put a switch statement in there and parse it, it's a lot better doing instance of comparisons and other things like that. So built into TyphonRT is actually the Typhon activity, and during the switch of orientations and stuff like that, there'll actually be a fired message out with the Android configuration and orientation settings, and then you could handle that, how you want to, whether that means redrawing the screen or figuring out what you have to do for the change in orientation. But the one thing that defines that in the Android manifest is this one parameter that you add to the activity. And so that will stop you from receiving or restarting the activity during configuration changes and keyboard, if you have the G1, when you flip things, the keyboard up and down. I really recommend everybody to definitely look into the information on the Android resources section and documentation, because that's one thing they've actually documented fairly well is the Android manifest XML file. There's a lot of things that you can do to control your application at that level, and it's quite useful. Now, of course, I put a little note in here, insert theme info here. But we'll go over to that. Like, another thing that's really kind of cool that you kind of should pay attention, or definitely keep in mind, is the theme info is a great way of actually controlling how activities, how they're actually presented. And one of the things that's kind of frustrating, say if you have an OpenGL application or some sort of 3D application going, and you want to start like a configuration, like to change your controls, to configure your controls, if you do nothing and you pop that up, it'll actually like hard stop the activity below, at least on 1.5 and 1.6, and restart it when you disappear or get rid of the configuration activity that rides on top of your game. What you can do though is you can actually have a you can make a custom theme and have it so it only like partially occludes the the activity you pop up, and only partially occludes the 3D surface below, and it doesn't go away. So it's kind of cool in the sense that that's a very powerful thing to be able to manipulate, and it's all through the XML, not in the application. So it's very important to take a look at Android Manifest, take a look at what you can do in the theming system, and also like right here, like you can set up like all the no title bar, full screen application. No background's kind of important because it's actually faster or more efficient if you don't set a background drawable. And I think by default there's probably something, but if you set like a at null in the theme, then it's just apparently more efficient. So yes, that's theme information. So themes are important to look at in addition to Android Manifest. Ah yes, the resources directory. Now, there's a lot of little tags that you can add to folders in the resources directory to, like the landscape one I think is -land and -port if you wanted to put specific resources for those kind of changes. And if you guys have been working on 2.0 devices and up, or high, the high density devices, the different, after 1.6 introduced HDPI and MDPI and LDPI for like low, medium, and high density resources. Well, that doesn't work on 1.5, which kind of sucks, you know. So like, how do you be able to, you know, utilize resources in 1.5, but at the same time have it work on later versions? And they have finished the resource system for 1.5, and at the time, 1.5 has, you know, -120 DPI, and that's actually synonymous with LDPI. And drawable, you know, -240 DPI is actually HDPI. And surprisingly, it'll do nothing, at least the 240 stuff. If you have a G1 where you don't actually have, you know, high density, you know, a screen or anything like that, it'll just do nothing. So if you put resources in there and the 240 DPI drawable directory, it'll just be fine on the G1, but it will actually work. So it'll actually treat it like it's an HDPI folder on 1.6 and above. And one of the tricky things that you kind of have to do, and like there's automatic scaling with 1.6 and above, which is kind of frustrating. So if you have a bunch of resources and what would be your MDPI, or you can just label it drawable, they'll be upscaled or downscaled depending on the screen size. And well, you don't want that with OpenGL. Unfortunately, there's a big limitation in OpenGL where you have to have a power of 2 image. So whether it's, you know, 64 by 64, 512 by 512, or you can have, of course, slightly different as long as it's a power of 2. Well, if the automatic scaling goes on, it changes your image size and causes OpenGL to say, what? You know, so what you have to do is actually, and Justin talked about it a little bit, is, and this is where the drawable directory comes in. On 1.5, there's no scaling because that's the size that it expects, you know, to be non-scaled for the G1 or 1.5 OS. On the 2.0 and above, it will scale, but there's additional methods now in bitmap class to actually force it not to scale the image when you load the bitmap. And in TyphonRT, there's a unscaled bitmap factory. So very similar to bitmap factory, except it will call the proper methods for you unless if you're on the right, if you're, you know, depending if you're on 1.6 or above, or if not, then no scaling happens anyway if you're on 1.5. And one other cool thing that you kind of actually can do is, like, a lot of people wonder, like, what, you know, I mean, the 9-patch stuff was discussed last month as well. And it's handy in the sense that, you know, you can have a scalable, stretchable image. And a lot of people just use it for, you know, the XML layouts that you can do. But you can actually tell if the bitmap is a 9-patch. And one of the really cool things that you can do is composite 9 patches, but treat them as a bitmap. And you can actually say, I want to draw this 9-patch as, or make it a particular size bitmap. So it's not attached to the XML. So you can actually, an unscaled bitmap factory will allow you to do that. If you give it a resource, you can also give it the size that you want it to return a bitmap. And if it's a 9-patch, it'll actually draw the 9-patch to the size that you give it to and return that as a bitmap. So that's pretty handy when it comes to compositing different things and still being able to use 9-patches. Now, I didn't really get to put a whole lot, unfortunately, on all the blending modes, which are really handy because it's just like, well, I guess the best way to kind of explain it, most people have used Photoshop, right? I mean, you have a lot of tools like the color burn and like all the different, you know, of course, like the opacity and stuff like that. You have the ability to apply filters to images. That's what a lot of the PorterDuff blending allows you to do, and it's part of the Android 2D API. And it's kind of untapped, unfortunately. You don't see a lot of people creating, like, you know, very interesting effects with it. And it's too bad, darn, if I just put, there's a couple images I could show that are pretty easily, show you what you can do. Well, actually, the intro screen, like the intro, like screenshot demo thing, I have a tiled image, but then I apply a gradient, and it's not add, it's one of the Porter Duff blending modes that will actually take the basic flat gradient color and apply, or the tiled image, and then apply a gradient but blend it into it, so it looks like it's actually the tiled image correctly to size, but with a gradient. And so you can do a lot of dynamic things where, and it also allows you to get away from having, like, say if you had to make a custom image 854 by 480 for the droid, or for some of these devices, and make a custom image that fit 800 by 480, that's a lot of wasted space. So if you can actually tile things and come up with, like, and composite like a background image that fits the size of the screen, you can save a lot of space when it comes to resources. And I mean, and you also, hey, the tablet that's, I don't know, the higher resolution, 780 by 1024 or something like that, everything's just going to work. You don't have to make another resource that's going to be super huge, first off, and fit the size of the tablet. All right. Now, all right, this is going to get interesting, I guess. Well, this does get slightly more technical, and unfortunately, super huge. And unfortunately, off like that, fit the size like that of the like that, 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 like that. Now, all right, get interesting. Well, this slightly more super huge off. Fit the size of the Now, all right, patch this. Get interest. Patch this. Patch this. Well, this patch this. Slight patch this. Slightly more patch this. Patch this. Super huge. Patch this off. Patch this. Fit the size. Patch this of the patch this. Can actually all right, can actually get interest. Well, this slightly more super huge. Fit the size. All right, get interest. Well, this slightly more super huge. Fit the size. All right, can actually get interest. Well, this can actually slightly more if you guys remember linear algebra or anything like that, is a matrix. So if you had to store the matrix format, 3x3 matrix, that's 9 parameters. But the really cool thing, the other 6 ways of defining rotation is only requires x, y, z, and w. So if you have a vector 4, or like a class that stores 4 floats, you can then store all these different types of rotation details, and built into the entity system in TyphonRT, like if you are storing something in a particular type but request it in another type, it'll do the conversion for you. So that's pretty handy in the sense that I'm not forcing you as a developer to choose just one type of rotation way to store things. You can actually store it with a lot of different ways. And so that gives you the flexibility, depending on the technology or engine that you might build on top of TyphonRT, to choose the way you want to do it. So I make no assumptions on that. And I guess the first one, this is actually in alphabetical order, and we'll just talk about a couple of them, is the axis angle format. So if you can imagine what that is defining rotation as in you have a direction vector that points this way, and it defines the rotation if my arm, if things were going to rotate around, the position. So you can have a direction vector, then it defines the rotation. So that's axis angle format. Degrees, everybody should be familiar with. 360 degrees or radians is the other way that you can define just 0 to 2 pi as your circle. The angles you can go around. Quaternions we'll skip because that gets a little Gets a little crazy. Spherical, I guess we'll kind of skip, but basically what that is kind of like a polar angle. And polar coordinates are, we'll skip that one too. But very handy, very cool. Because actually a lot of the audio stuff that I deal with is actually built kind of more in a spherical format. It's called spherical harmonics, is kind of like the technique that's used. Yeah, we'll skip that too. How many people are familiar with the FFT transform? Fast Fourier transform. Yay. So the fast Fourier transform is actually, it's a way that you can recreate a 2D signal by a summation of sine waves. It's kind of like the basic way you could do that. Now, that's great, that's 2D, but how do you recreate the way that a 3D wave propagates in space? You actually do a summation of spherical harmonics, which is just a slightly more difficult equation, and it's all just kind of like sine cosine, and I am glossing over a little bit. But it's kind of like a summation of a 3D math formula that gives you how audio, or light even, so like you'll see it used in lighting calculations for 3D graphics. But that's more advanced stuff, so we'll skip over that too. But it's really kind of cool. It's similar topics if you know. And one of the great things is that there's such a corollary between audio and graphics development. So it's kind of hard to start learning up some of the math stuff. And the majority of my experience has come after my degree. So I unfortunately didn't get the greatest. Well, I mean, I went to Cal Poly, State University was great, but it really didn't. You didn't get a chance to apply a lot of this stuff. So I found the applications after the degree. But the last two rotations, actually these last 3 rotations are kind of the most used and kind of really important to get a handle of. And unit circle. So when you have a vector and it's kind of pointing that way, and it could be like a certain length, like my arm's pretty long, let's call it like a vector, kind of like it's a length, it's got like a length of 3. But you want to just get it into a standardized format, and that's called normalizing a vector, and that's where you kind of get it to what's called a unit length, or imagine a circle that has a radius of 1, and it's in a 2D context. That's the unit circle, and in Cartesian coordinates, which is your standard, like if you look at a graph, and I'm probably going to do this backwards but you have things going like up's positive and down's negative. That's one way of representing the XY axis, but in screen coordinates, usually when you're doing 3 or 2D stuff, down is actually positive. So 0, 0 is up in the upper corner, and when you increase the y-axis, you're actually going down the screen rather than going up. So there's 2 different ways of storing rotation, and it's really kind of cool because as long as you have a direction, you can do what's called normalizing. It's kind of taking, you take the square, it's a really easy, you just get it down to a circle, and let me see if, I hope I have one of those images. Oh. I hope I copied it over. I don't know if I did. Bear with me for a moment here. Hey. Whole bunch of images. Oh.
Basically, you're just saying you scale everything so your maximum is more.
Yeah, and it gives you a lot of interesting like properties. So once you get it, imagine like a projectile. If you have a particular, if you say your motion for a projectile is going really fast, like 15,000 units. We'll just call units anything, feet, meters, whatever. And you hit a target, so you have a direction, but that direction is scaled. And it's kind of like it's really, it's moving really fast. What you can do is you can normalize that and get it down to length, a unit, or a length of 1. Then you can reverse it and use that as scaling an explosion that goes the other direction. So a vector could be any length, and can contain some data, but you can get it down. Once you normalize it, you can use it for rotation, and you can either store it in again, like the screen format or the other format. Yes, Cartesian or screen. Now that's 2D. Basically the same thing, and we kind of talked about unit sphere. Imagine a sphere of length 1 or radius 1 all around the sphere, and you could use the same thing for rotation. And I guess, unfortunately, I didn't get like more information. That kind of brings up to the subject of parametric equations. I'm not too sure. How many people are familiar with parametric math? Yay! Sure. The question was, what has been my experience with dealing with floating point versus other formats like fixed point, and how that responds on slower devices, say if an older OS, and the newer devices. Well, a lot of the newer devices actually have a floating point unit, so you're kind of free, definitely free, just to use floats. And when it comes down to it, you know, I didn't all of a sudden go, oh, now I got a G1, I'm going to have to change all my math to fixed point. That's really annoying. And fixed point's a way that you can actually represent like float type, you know, what do I want to say, not real or whatever, anything with a decimal point and an integer. So you actually kind of subdivide the bits in an integer to store, you know, the mantissa, I guess. But that's really kind of annoying because you're not going to get that much extra performance. And like, who really? We got so many cool devices now that can run so much better stuff. I mean, there's very little reason to build like a specific fixed point math into the into an engine, especially now. It's like all devices run rather great. And I mean, there wasn't as much of a hit for floating point even on the G1 because there's other things that limit your performance a lot more than the math side of things. And that's what really is limiting, even on like some of the all the better devices right now, is your fill rate. So if you fill the full screen and you fill it with extra stuff, and I have a video that will show some of that, your frame rate's going to drop way out. You know, if you're drawing a lot more stuff on the screen. So the question was, what's some of your strategies on dealing with fill rate? And my answer was don't draw as much if you can. But obviously that's kind of hard to do, you know. So I mean, I'll show actually, you know.
Tricks.
You
don't have any tricks up your sleeve.
No, fill rate's the big limit. Like that's actually what kills all performance. So yeah, going back to the floating point thing, you know, there's other things that are going to kill performance. So I guess we'll jump into a little OpenGL goodness. Now, unfortunately, I don't have great slide notes and all that kind of stuff. But the difference between OpenGL 1 and OpenGL 2, now, the first generation of Android devices only supported OpenGL 1, 1x, OpenGL ES 1x. And the difference there is that it's kind of like a big giant state machine where you have fixed functionality that you turn on and off. And so but with OpenGL 2 and beyond, it's a programmable system where you can actually apply your own algorithms, and they're called shaders, and attach them and do different things. But then you have to actually manage all that stuff that you do with OpenGL 1 and have all that fixed pipeline stuff. You have to re-implement it kind of in your own shader system. I mean, it's pretty standard stuff, so it's not too hard. But we'll talk a little bit about, and I'll hopefully get into some of the code so we can kind of step through things and see some of these state changes and see how that affects you know, how you write your code. So one of the things that's really kind of cool, and I don't think I actually made a video for it. You'll see it how. Well, what it is, and unfortunately I don't have a graphic slide for it too. It's a technique called a skybox. So it's a way that instead of drawing like a very complicated scene with your whole background, like a big panorama of stuff, all you have to do is draw a cube around the user and move that. And if you build that cube, just 6 textures, and have it seamlessly meet at the corners. And there's various applications and graphics packages that you can get to easily do that. You can actually create very efficiently, your background and your panorama. And we'll see that when I show a little bit of the Ariga 3D engine, but I actually just didn't make a specific video demo, unfortunately. But the code actually, it's not too bad to take a look at, and it'll also get us into some of the parts of TyphonRT. And it's not too long. I don't know. Are you guys want to dig into some code? You ready? Yep. All right. Let's do it. And this also gives us a chance to talk about how you have to send data to OpenGL. How many people are familiar with the bytebuffer package? Anybody? All right. We got one. All right. Well, whenever you're using like JNI, and from Java, when you're going to use OpenGL, OpenGL is like a native system. So you have to pass data across that boundary, and the most efficient way to do that is the new I/O interface. Now, in TyphonRT, like I actually have extra functionality wrapped around the Java Neo interface. So like this vector buffer 3F here is actually backed by a Neo buffer, and so it's kind of cool because you can read and write vector formats to it, and not have to deal with. It just makes it a lot easier to work with Neo buffers, and you could choose different, like 2F, like if you have like, and we'll see in a second here, like textures. When you're dealing with texture data, say your texture is 512 by 512, and you want to draw the whole thing. You index it, so 0 to 1 draws across the whole thing. If you want to draw a subsection of that texture, it's 0 to 0.5, and 0 to 0.5 is, you give those 4 coordinates, and it'll draw the top quadrant of a texture instead of the whole thing. So essentially, the skybox, you pass in an array of textures. It has to be six of them, otherwise it'll cancel out. You can get the diameter from the texture, and now the texture class is actually a class also from TyphonRT. And a lot of the engines that you deal with, you'll have a texture class. Again, we check if the diameters are all the same. If they're not, we cancel out as well. And now this will show you part of the state engine type stuff. Like every texture, when you generate it, like you'll call a function like generate texture, and you'll get an ID back. So you have to store that ID, and that refers to the actual texture that you uploaded into OpenGL, and so that's how you'll actually reference it. So when you create the vertex and the texture buffer, the number of sides is 6 times 4. So that gives you there's basically 4 points for a square. And when you initialize it, here we can see that we're actually just for each section, you have the diameter of it, and you're able to you create just the 4 points that are around for a cube. So you store that. You're able to store that all into the whole vertex buffer, and you keep adding to it. So the whole vertex buffer stores all the vertices and the and all the textures, the texture points. And for the front, back, right, you just choose different. You were still using just the half diameter of it, but you choose the different points to get the cube. And you can see with the texture buffer, I mean, we're drawing the whole texture. Now, one of the cool things about the the TyphonRT vertex buffers is that with Java Neo, you only have like, I don't know, again, I guess not too many people have experience with it, but when you write into it, you have to rewind the buffer. But the really cool thing is that you have a read-write head with the vector buffer. You can actually duplicate your view of the Neo buffer. So you can write into it, and then you still have a read index that you could read into it, and you can rewind both of them, or they're separate. So that's just one nice thing about the additional functionality that I've added on top of Neo. Now here we kind of see some of the state changes that can occur with OpenGL. And basically, you can basically, it's kind of like having like different slots for if you activate like the first texture unit, and there's multiple like texture like units. So like you can and we'll talk about this as like when we get into the a brief view of like some of the Rigger 3D stuff. One of the cool things that you can do, and one of the things that you want to do for performance, is that unfortunately, even with, well, maybe the Galaxy S is all right, you know, but if you use, OpenGL provides like lighting, so you can actually have lights, and they'll illuminate the scene, but that's very performance hungry. That's you know, that'll kill your performance just like, you know, the fill rate stuff will, and some of the GPUs, like I think the Qualcomm Snapdragon only could support one light, whereas the Droid Power VR chip could support 3. So you have different, like, you know, there's different levels of performance on it, or different, you know, you have limitations depending on the GPU you're using. So if you just avoid lighting altogether, you can do something called light mapping, and that's where you can use 2 texture units. So you have kind of like I discussed some of that Porter Duff stuff, where you could blend and change the way a texture works. That's exactly what you can do, where you can have the lighting like a light texture that defines like how bright something is, and just combine them together. Now I know too, we're kind of all just diving into all this stuff, and it might be a little kind of, you've never seen it before, and there are specific things that I'm doing here that's different than some of the Android stuff. Like you might see like the GLB there. That's actually calling a generic, like a facade wrapper around OpenGL. So this class right here, when you call it in your application, works on Android, works on the desktop. It'll work with WebGL once I port, you know, TyphonRT to that. So some of these things that are not like super performance hungry, like you draw the skybox once every frame, and it's not a whole lot of code. You can actually use the generic GL binding that will call down to the proper one, whether on Android or on the desktop, and this is nice because then you don't have to duplicate all this functionality. So right here, you enable the texture unit. You enable the vertex array and the texture coordinate arrays. This push and pop thing, like there's basically I wish I had more images here, because it's so much easier to, you know, than me just telling you, because you know, a picture's worth 1,000 words, basically, especially when you're doing 3D graphics discussions. So, surprise, surprise, you know, no way. Yeah. So like you can have a model view. It's what's called the model view matrix and the projection matrix. The projection matrix is kind of how you define your view into the world. But the model view matrix is actually like the matrix stack of rotations and whatnot for the objects that you draw. So when you do these, like when you translate and you're able to push the current state onto a stack, do some translate, you know, the next thing here, I'm actually moving to the camera position, which is exactly where, you know, the person is, you know, from the camera viewpoint. But you want to be able to pop that off. You want to go back to the last state that you're in. Well, say you're drawing a bunch of objects, and those objects are located at different like points in space. What you can do is that if you're starting from the origin, like, so you actually have the stack cleared. You know, you're at 0, 0, 0. And you want to draw an object over, 10 to the right. You can push the matrix, do your translation, draw it, pop it off, and you're back to where you began. When you draw multiple objects, you can do that, but you can also do like I'm just doing translate because like once you translate and you rotate and you do other operations, you know it's just easy to have a stack, so you can pop off to a point where you know where you're at, basically. If that helps. So real quick, like the one thing that's really different about OpenGL, yes, is that you have to use vertex arrays or something else called vertex buffer objects. And the difference between the two is that a vertex array, you store all the vertice data on the CPU side. And every frame, you have to send that over to the GPU. Vertex buffer objects allow you to actually store that vertice data on the GPU. But they're almost the same, but vertex buffer objects are faster. Big problem, though, is some devices don't support it or will crash. Some devices will say they support it, but don't. You know, it's like, it's kind of a big mess. But once you pass over that, you know, that vertex array, or you give right here this pointer to it, you're able to do then just a bunch of draw calls. And you can see right here, this one call, you have 24 vertices in that vertex array, which define a cube. You know, 24 points in a cube. You're able to just call, you know, the index is 0, then you call the first 4, and you stored, you know, the front side in that first 4. But you also have to bind textures so that you can see that the different texture IDs, that changes the texture that you're drawing. So that's essentially how you send vertex and texture data over to OpenGL. Oh, it's actually functionally the same in OpenGL 2 as well. One of the things that is good and bad, I suppose, and you want to really watch out about it, is that all these state changes that you do actually affect performance. So if you do a bunch of like pushing and popping and translating, that will affect performance. And actually what you said, one way to actually improve performance in certain cases is actually to handle like all the transforms on the CPU side. So instead of like using the OpenGL matrix stacks to change things around, you can actually do all your rotation on the vertices points on the CPU side using however you want to do it, really. And pre-calculate, like, so you calculate all those rotations, then you're able to send all that down at once and not have to do all these different state changes. So there is an advantage of being able to do stuff CPU side, but it's only under certain cases, I suppose you could say. You can't do it all. I mean, and it really comes into play when with the JIT, with Froyo and the just-in-time compiler. Things on the CPU side are 2 to 5 times faster, and it actually is really cool. So it really improves what you can do with Java and other techniques of doing CPU side transformations. And again, if I wasn't so busy finishing all this stuff up, I would have spent a week doing a awesome, very clear presentation. So I hope this isn't, you know, me talking to just the, you know, the blank air or whatever. The question was, what's the licensing around TyphonRT? And it's definitely going to be open source, and I'm going to be doing the open core model. So I'm not too sure if you guys have, it's kind of something that's been bantered around over the last 2 or 3 years. And it's really trying to, you know, apply a business model to an open source project that's not freemium or not something like that, where you're just giving it away and maybe you're going to upsell features to other people. That works really great when you're like a web application and you have millions and millions and millions of users that you can give away stuff to. But I'm basically putting out a large core, the whole architecture of TyphonRT for free under GPL. So if you're doing GPL v3, so if you want the GPL and you want to pay nothing, by all means, you know, go ahead and use it. But you know, you have to follow the GPL requirements, which is also you posting all your source code for free as well. But I'm also essentially dual licensing it. But I'm not going to, I want to support indie developers. I want people to get their hands to this. I want you to make money. I want you to make cool applications. I mean, there's 70,000, okay, probably out of that 70,000, 60,000 trashy applications on the Android market. We need cooler stuff up there. So I want to give out, TyphonRT in a way that if you are going to commercialize your application, you have to register with me, and then I'll give you a commercial license. If you make more than 100K revenue per year, then I want to talk to you. But at that point, you've already made 100K with the project or TyphonRT, so maybe you want to kick down a little. But that's the open core part of it. And I'm also going to have commercial plugins that I may sell. And it's also we'll see if there's adoption and there's traction. Other developers, I'm certainly going to encourage to build on top of TyphonRT, and potentially they could sell their work or they could open source their work. So it's kind of like there's a larger core architecture that you could develop additional functionality and plug it into it. And some of that might be for pay. So you could have the free version of the core, but I come out with like this really cool model loading component that allows you to load 10 of the most popular formats and do all the animation and move guys around. But I might charge you $200 for that. But that's kind of cool because that's, I mean, when it comes down to it, you might spend hundreds of hours, working on just, or maybe not at all, maybe not even getting to the point where you could do some of these more advanced things. But you could easily apply it, as a commercial add-on, basically. So it will be free. It's going to be freely available. And I'm really, really, really interested in trying to get people to learn about new things, to take their career or their interests and really move into a new area. And gaming is a great area to do that. Engaging interactive apps for mobile devices is a pretty fun place to be working in. And if you don't live in San Francisco, you might even become an indie gamer or indie game developer. Unfortunately, there's not a lot of indie game developers in San Francisco or the Bay Area in general, just because of the higher rent and stuff like that. I mean, I guess a side tangent thing, it was really kind of fun. Like the Google I/O, although I didn't get a ticket for various reasons, I guess we won't really go into it. But I got a chance to hang out with like a bunch of indie game developers, and they're all spread across the country, and most of them weren't living in a metropolitan area. So, but hopefully you guys can make some great applications, get it up onto the marketplace, and just do something new. I mean, I really want to have TyphonRT out there where folks can again learn new things. I'm really going to apply or try to do. Is anybody familiar with like the Khan Academy? It's kind of like this guy that just made like 1,500 YouTube videos, and they're all like 10 minutes short or 10 minutes in length, and he covers all sorts of topics. And there was like a bunch of the math stuff's phenomenal that is up there. It basically goes from like 1 + 1 through differential equations, and it's all like really friendly narratives, and it's actually something that you can learn the material without having to go get a degree. And there's a lot of stuff that actually is really good in that whole his whole library that applies to all this real-time app and game development and some of the math. I want to do something very similar for Android development. And it's kind of cool because his material is Creative Commons, so I might remix some of his stuff with direct applications with Android and have all the source code so you can see all the really cool math stuff. And it's, I want to make it engaging. I want to teach people new things. And TyphonRT is kind of a vessel to do that, I guess. So, well, that is interesting. TyphonRT is going to ship with no real audio support right now, so that's something I'm going to add later. But I want to do it in a cross-platform way so that you can create your audio resources and it works all on the desktop and Android. But if you make a real-time game or application with TyphonRT now, I mean, you just use the Android media stuff and play your sounds that way. So you just have to manage it with the current Android SDK. I But yes, I guess. Oh, we were gonna watch a video. One of the like lame things about different devices, and this has nothing to even do with Android per se. It's like a device limitation that comes from the OEM. This is the Droid running a 2D, like a simple 2D game, but it's really supposed to be 60 hertz. And while it looks kind of high at first, it's going to drop off, and you'll see stuttering. And I mean, it's kind of hard to see it, you know, on a video. Yeah, okay, yeah. So like anybody that's got a 2D API game out now, it blows on the Droid, or they're stuttering and stuff, and there's nothing you can do about it. Just absolutely nothing. I'll pull out the Nexus 1 here pretty soon. Oh yeah, see, like that doesn't happen on the Nexus 1, you know. So it's kind of sucks because like there's device differences, and we're talking about something the programmer has no control over, none whatsoever, and you're going to get a bunch of bad reviews in the app market because there's a problem with the device. And it's like maybe they. And here's the thing that sucked is that originally when the Droid launched with the 2.0 OS, it kind of did this. When the 2.01 OS came out a month later, it fixed it. When the 2.1 OS came out, it came back. You know, it's like, and I don't even think they're trying to like do battery save. I mean, they'll maybe claim, oh, we're doing some weird, you know, capping, so the performance is, no, the performance is worse. Maybe you're saving battery, but I don't know. The Evo is the worst culprit, and we'll take a look at that video next. And it's too bad things are stuttering here, because this is direct video I just recorded just before the presentation, and so. Yeah, when I tilt it this way, it looks a lot better. And this is actually like the first, it's a 2D API example, and it's actually like the first thing you're going to learn when you go through the TyphonRT tutorials. So Nexus 1 will be running at pretty much 60, and it's going to be a lot smoother. You're not going to get the stutters. And again, it's hard to see over the video. Well, that's maybe just the video. Yeah, it's the video playback. So. Well, the top one, the Droid's going to actually stutter the graphics. It's just, I mean, like you can see. Oh, I guess. Well, shoot, that doesn't really do very well, huh? You can't see the frame. Yeah, sorry. I'm looking at it here, going like talking about something that unfortunately you can't see on the wall. Yeah, like the Nexus 1 on the bottom is doing 60. The Droid's doing like 30, and like the problem with the Droid, whatever weird capping they have, it's sort of at 30, then it bursts up to 60, and then it drops down to 30. And that's kind of the stuttering that you see, is that, I guess, I mean, the more, all right, this is the Evo madness. So this is just the most simple, like, 3D demo application you can do, and I'm trying to render it at a 60 hertz right now, but it's locked toward, it looks like it's capping at 30, and I just dropped it down to 20. Well, crap, it's not doing it at 20. Well, what's going on here? You know, I'm actually calling the frames like to actually render at 20 right now. It's still doing its weird capping crap. Why is that? And it's because the capping they implemented is broken, or it's just like the most substandard thing that they could do. And like they claim they did this for battery performance. And then they also, there was a rumor that went around that it was because of HDMI on device that they had to be 30 frames per second. There's a thing called an if statement. If HDMI connected, crippled device. You know, but, you know, it sucks because, like, we're still at 30. Oh! We finally jumped to 20. So it finally left their actual, I was almost going to swear there, messed up loop. But now I'm actually in control of it. I went down to 15. It locks to 15 right away. Because I'm actually calling the redraw at 15. We're going to go up to 30. That's what locked, well, if the, okay, there, that's what like proper capping should look like at 30 hertz. Like preventing it from rendering faster than a certain rate. Yeah, capping the rate. So like I dropped it up to, or I think I just put it up to 60 again. And the capping kicks in, and it kicks in right after 30 at some point. If I go back down to 15, you know, it's still in this weird capping loop. And it's like, I mean, maybe they had a beginning engineer like write this, but I think it really came down to the point where they were just like leaking so much battery. They had battery issues, and they're like, all right, we'll just automatically, or like HTC did this, not Google. You know, Google didn't even know about it, or so they claimed before the HTC shipped. It's hard to say what they're doing, other than it's horribly, like, poorly implemented. It's like it almost takes control over the whole rendering loop, because, like, the way that you render a frame in OpenGL is that you can just tell it, draw my scene now. It's called swap buffers, and EGL swap buffers is the method that you call. And because of the Typhon clocking system, where I can set, you know, different subdivisions, you can pretty accurately do capping yourself. And so that's another, like, hilarious thing, like, from my perspective, is that here you have, like, a manufacturer that's, like, you know, making their device suck and apply this, like, weird capping thing across the board to try to save battery power. But as a developer, you could do it yourself if you really want to save battery power. Basically, the question was, is there a way to get around the capping if you use the native, the NDK or the native development kit and not the Java layer? And the answer pretty much is that HTC, as far as I know, modified Android to do this. So they made the modifications to mess it up, and I haven't tested the NDK in terms of this capping issue, but I'm sure it's the same. You know, I wouldn't see why they would, you know, cap Java and not cap the native. Well, that's actually a really good point. The question was, or the comment was, if you're writing an application and you detect that you're running on the Evo, can you not circumvent the capping? But as you saw, like, I was able to do a very steady 30, and that will make your interface, like your game, or you know, if steadiness is what counts. So this herky-jerky kind of, you know, messed up capping is going to actually, if you hold the Nexus 1 to the Evo, I mean, if you guys want to take a look at it after, and the Nexus 1 is going at 60, and the Evo is doing this weird, you know, 30 to 40 back down or whatever, you're going to go, the Nexus 1 looks clearly better, you know. So if you could then make the decision, or make a branch in your code to cap it yourself at 30, it would look better than the false capping, or the broken capping. Mm-hmm. Yeah, like there's a Android, I mean, I can't think of the exact, I mean, I generify it to just like a platform info class, and you can get the device name, the device family, and that's actually when I mentioned that XML system for like loading stuff, you use the device name and device family and OS version and other parameters to make decisions through, you know, the XML system. But yeah, you're right. You know, if you're on the Evo and you want to have something more steady, it's better just to lock it at 30 yourself, you know, instead of introducing or dealing with that. Here's another funny thing, or I say funny, but it's not. The G1, like 1.5 and 1.6, had some big problems with touch floods. So like touch events, like when you actually touch the screen, you can see here I'm actually just shooting. Now I use my finger, and frame rate drops down to like 10. And I'm not doing anything different. I'm just using the touch event thing. So that was a big, huge issue, just things we were kind of bummed about, you know, back with 1.5 and on some of the older devices, is that just by using the you know, a different you know, a different way to get your data, or like your event data in, will highly affect like the frame rate performance. Wow. Yeah, but luckily it's not as bad now. But it still kind of happens. You can see, like, when you're using the touch event data, it's not as good. And I mean, another frustrating thing, like, when you actually use the sensor data, like the accelerometer and stuff like that, whoever implemented it on the Android, you know, down deep in the bowels, there's new events being created, new objects being destroyed, there's just garbage being created. The same kind of crap happened on Java 2D. When you redrew like an element, it would create a new rectangle just to define that element. But that garbage creation affects things. So even just using like the accelerometer sensor, you'll have garbage build up and a garbage collection occur. So that is kind of frustrating when it comes to just, because you can't change that. I mean, it's just the way things work. Garbage is created when you use some of the sensors, and and that's that. I actually do certain things to improve just the basic Java performance of collections to limit garbage. I wish I had a whiteboard just to put something up, you know, like, but, oh, well, you know, it's kind of hard to see, I think, for everybody. But, you know the for each statement? where you can just have a collection and then put, like, say if it's a collection of strings, and you just do string whatever, and then the colon and the collection. What's going on there, actually? It looks like it's innocent. But what's going on? Does anybody know what's going on underneath the hood when you use a for each statement? Yes, it creates an iterator. So it creates a new object, and if that was in a tight loop, and if you had one, that would suck. But what if you had all your code using for each loops? You'd be creating like a new iterator, new object, new object, new object repeatedly in a real-time loop, and that's going to create garbage and get stutters occurring when garbage collection happens. In TyphonRT, I re-implemented all the collection classes, and I just call it like fast linked lists, fast hash map, where you can still get create new iterators, but I actually store, and I have my own iterator type, like a reset iterator. So most iterators you can't reset to the beginning of the collection. It's a one-use thing. But I just rewrote some of the code so you can store, like, it's basically you have that for loop, but you call in the collection get recycled iterator, and so you can recycle an iterator. Of course, when it comes to having a lot of collections and stuff like that, by default there's only one. So if you have like some silly, or not silly, but like an algorithm where you have to call, you have to traverse it multiple times, well, eventually you're going to have a problem, and you're going to run out of recycled iterators and grab one that you're already using, and it's going to mess stuff up. But if you intelligently design some of the algorithms, or like the way that you use the recycled iterators, you're not creating garbage. And that's an important thing when it comes to collections, because using the linked list collection has benefits over an array list or an array, in the sense that you can adding and removing to a linked list is very fast. And adding and removing to an array, like especially like a hard locked array, I mean, you have to do a system array copy, create new objects. One gets, so you do have stuff. There's penalties, and I was going to mention, like, back when I mentioned that whole change listener, or the ID change listener system, even on the Java desktop J2SE, there's an event listener list like object, so you can kind of store event listeners. Well, that implementation on Java on J2SE actually does destroy an array and do a system array copy every time you add and remove a listener. Yeah, it's very expensive if you're adding and removing listeners really quickly. And I mean, unfortunately, maybe we don't have time. I mean, I'm going to be going over like so much more material in the tutorials. But I have a whole entity system, and I hope I can talk about it a little bit, because I'm really, really proud about what I was able to do in creating an entity system that's scalable, fast, and expandable in a way that it can be built upon. It's not based on object-oriented programming, basically. So most of you are probably familiar with object-oriented programming, but there's a different way that you can organize things, component-oriented programming, where an entity, and if you're doing an object-oriented entity system, and a lot of people start this way, and they'll eventually find that it ends up to be a big, gnarly mess. Like at the top, of your entity tree, you have the entity class, or whatever you want to call it. Maybe you start going down, these entities can move, these can't, these have AI. Well, crap, you want to add AI over here now, so you move AI back up to the top. And then you start getting an anti-pattern. If you guys are familiar with design patterns, there's also anti-patterns that are bad things that happen based on the strategies that you use. And object-oriented programming has its own set of anti-patterns, and that one's called the blob anti-pattern, where if you build an entity system, eventually, like I started with an object-oriented entity system, and eventually my base entity class was like 4,000 lines of code. And I just need XYZ for a rock over there. Like one line of code to store where the rock is, But it had all this extra stuff that just got moved up to the base class because I wanted these other classes down here to share functionality. And so it's like, and you also use a lot more space. If you're only able to, if you have an entity that doesn't move, all you have to store is its position. Maybe its rotation. Like four to six floats or something like that. And but if you have like base class also stores acceleration. There's a bunch of other parameters like your angular acceleration, like how fast you rotate, your angular velocity. If you store all that data in that base class, you're going to have a very heavyweight entities. So you're only going to be able to create so many of them until you run out of memory, and that is a problem. Although I don't have it in the notes and stuff, you're pretty much limited to about 16 megabytes of memory and your standard activity. I mean, the only way to get around that is if you recompile, create your own custom ROM and probably change a setting. So that's a pretty hard limit. And if you have that has all this extra cruft to it, I mean, you may only be able to create 500 entities, but if you're only storing XYZ, you could create 3,000, 4,000 entities or a lot more if you do component-oriented programming. Yeah, I mean, basically kind of consider component-oriented programming more kind of like the entity system then becomes like a vessel. And then you're able to slot additional, for movement, maybe you just have a position component that has X, Y, Z. If it moves, you can have more of a kinematics component, which also stores velocity and acceleration and other parameters. If you're doing even more physics, you might have a dynamics component, which will store its mass, the coefficient of friction. I mean, there's a lot of deep stuff that I'll be going over in the actual tutorials that we're just not even going to be, get close to cover. And in a way, I do apologize because I've been focusing 100% on the engineering. I mean, I even wanted to get a code dropout, maybe, just so you guys could go check stuff out after this presentation. And I literally worked all weekend trying to do this release engineering aspect of it. And it took a lot longer than I expected. I even did a push Sunday at 2 to last night at 10 to try to get this whole thing ready so I could do a code drop. And I got 90% of the way there. And I didn't have a lot of time to prepare for this presentation. So, I mean, there's a lot of material that's very exciting and very engaging. And I hope to present it in a way that's even better than what you're seeing here for sure. Now, I want to use the last 5 minutes actually to quickly talk about some other projects that are out there. And there's some really good ones, and there's some really good blogs actually too that are worth subscribing to. The first fellow that I really like his work. He's a guy from Austria. His name's Mario, and he's part of Bad Logic Games, or I think it's just him as a developer. And he's put out some pretty cool physics games. But he's got a small little library called libgdx, and it's similar to TyphonRT in the sense that he does have some functionality to run it on the desktop and on Android. But it's a very to the metal kind of. He doesn't have a lot of additional stuff and libraries and components that I've built on top of TyphonRT, no entity system, nothing like that. So you get some very raw, really great performance stuff. And the other two engines that are worth looking at are And Engine, and that's from Nicholas, the fellow who runs anddev.org, which is a good forum. Until I get all my forums up and stuff, I answer questions there. I mean, I don't really like the Google email list, developers email list, because there's so much traffic and there's not very focused and specific. But the anddev forums is pretty cool. There's people answering or asking and answering questions there on very specific topics. So that's a good place to go. And that's anddev.org. And he started this engine in March, and it's coming along. It's pretty cool. He actually emailed me around March to say, when am I going to be done with TyphonRT? But when I told him, it's going to be a couple more months, he just took the bull by the horns and started his own engine. And I think that's really cool. I mean, it's a great way to learn, obviously, if you've never done anything engine-wise. And he's got a pretty good architecture started. The other one's Rokon 2D. And there was one of those flight control games that was made with the engine. And both of these are open source. I think Apache license, so freely available. Rokon 2D, R-O-K-O-N. So the big difference with And Engine and Rokon versus TyphonRT and libgdx is that they're more of a managed environment where it's kind of more of a black box, where while you can create entities with both those engines, you really have limited capability to control how things get rendered. And so here's an example. I mean, this is something that Mario just posted to his blog, and I'll get the link to his blog a little bit later here. And it's just drawing like 32 by, a 32 by 32 pixels sprite all on the screen. So 336 sprites, filling up the screen. And here's, the AND engine on the Hero, older device, they get 17 FPS. On the Nexus 1, 41. libGDX, that does all the CPU side stuff for optimizing batches of images, gets 51 FPS on both. And you'll get something very similar, to TyphonRT also will allow you to do something like that. And that's one thing, I mean, I didn't really get to get into it, but the whole entity system and even how things are, there's interfaces and component, ways that you can, if you don't like how I did it, all you have to do is replace, one little, you're freely available to not replace the whole system, you don't have to tear apart the whole thing, create a crazy branch of your own specialized version of TyphonRT. I put in so much time to try to make it flexible where if you want to change something, you can just slot in your change and not have to rewrite, or worry about managing your own whole separate code branch.
Are you using fastmath? Are you leveraging his fastmath?
Sorry?
Is TyphonRT leveraging?
No. I have a separate project. But I was really cool to see it because there's nobody else doing something similar to TyphonRT, and this one fellow is, but he's also doing it more of in a part-time fashion. And it's kind of cool. His blog too. He talks about different topics, not just Android, but a lot of specific, a lot of stuff that's very interesting. And he's got some great games on the Android market.
So first of all, thank you.
Well, yes.